And welcome back to 2.3, Elements and Compounds. At this point, we're going to recap what we've talked about in terms of substances and mixtures, and then we're going to talk about how we write them out chemically using symbols and formulas. So first here, we've been talking about matter as the overarching theme here, and matter can be broken down into two types of entities, I guess. You have what are called substances, pure substances, some people will say, pure. And then you also have mixtures. A pure substance is an entity of itself, has a definite composition, a uniform composition. It is always the same, as opposed to a mixture, which is a blend of substances and can have a variable composition. Now, mixtures can be broken down into two types. You either have homogeneous mixtures, so U there, US. Homogeneous mixtures, which have one phase, a single phase, the same phase, which is what the prefix homo means. And then you also have heterogeneous mixtures that have different phases. And these mixtures, whether they're homogeneous or heterogeneous, can be separated using physical means. You can boil off water. You can filter off a solid, for example. As opposed to a pure substance will either be an element or a compound. And the elements and compounds cannot physically be separated. However, you can chemically separate a compound into smaller compounds or even all the way down to elements, and elements cannot be separated chemically. You have to do nuclear reactions, which is actually covered in chapter 25, and you'll have an opportunity to do that if you wish. So that kind of summarizes what we've been talking about in terms of substances and mixtures and the differences in ways you can separate them. Now, scrolling down, there are lots of different types of elements and compounds, and so we have to have ways to express them. Well, chemists are going to be using chemical symbols to represent elements, and they're going to be using chemical formulas to represent compounds. For example, different chemical symbols would be something like H for hydrogen, O for oxygen, C for carbon. Gold is actually AU, and you'll learn that in just a little bit. They are single letters or pairs of letters, could be two-letter combinations, that represent those elements. As opposed to a formula is going to combine all the elements in the compound, and it's going to also tell you the number of each element, numbers of atoms of each element in that particular compound. And we've written these out already. Water being H2O, carbon dioxide being CO2, glucose being C6, H12O6, and those you've written out before. Those are formulas. But because these symbols make up what we call the chemical alphabet, you actually are going to have to memorize some of them. I'm not real big on memorization. I think that if you learn the concepts, you can put things together, and that's a whole lot better than trying to memorize everything. I will not ask you to memorize much in this class, but you will have to understand the relationships among the different concepts that we're talking about. Element symbols are slightly different because we're going to be using these so much. It really pays off to have a lot of them memorized, or at least some of them memorized. And so here down below are the different elements that you're going to have to memorize, all from the periodic table. Elements 1 through 20 you're going to have to memorize, 26 through 30, etc. These are the individual elements that you're going to have to memorize, all from the periodic table. Now you can either make flashcards where on the front of the flashcard, here's our flashcard, you have the symbol, say H, and then on the back side of that flashcard you have the element name, hydrogen. And you can make one flashcard, again these are opposite sides, You can make one flashcard for all of these elements. I think there's approximately 40 of them in there. Or on Moodle, there's a great little practice element quiz that I put together for you, and you can just run through that as many times as you want to practice these things. You're going to want to do that because as we talk about formulas, as we talk about different compounds, you're going to be seeing these types of formulas all the time. And if you don't know what these elements are, having to look them up all the time is going to be a pain. So I really, really encourage you to do this. This, again, will be one of the few things that you have to memorize. All right? That concludes 2.3.